Hello everyone, welcome to NS Academy. So today we are going to learn about definite integration and in specific piecewise functions. So in general, when you have a function, let's say this is the x-axis and let's say this is the y-axis. So for say we have a function like this which has the equation y equals to f of x, right? And let's say there are 2 points on the x-axis, this is A and this is B, and we extend these points like this as a line which is vertical. The area covered under this region, basically between x equals to A and x equals to B, the area covered between this region, if y of fx is a function which is integrable as it is because it is continuous in the interval a to b, is given by the definite integral a to b f of x dx. This is the area. So this is basically the definition. This is how integration emerged as when Newton had defined it. This was called Newtonian calculus. So Newtonian integration simply states this. But today what we are going to see is something along the lines of piecewise functions. Okay. So a piecewise function is basically a function which is defined in 2 parts or more parts. So 2 or more parts. Okay. So let's say a function goes like this, and this is the point x equals to a, let's say. So it goes like this, follows a certain curve y is equals to f1x up to this point. And then when it reaches here, it starts behaving like something else. Let's say it starts behaving like a line after x equals to a. So when you define the function, this whole function, you are going to define it like this. Y equals to f1 of x, and this is true when x is, let's say, less than a. Let's say the function goes up to some all values where x is less than a. It is defined for that. And this function, let's say this line is mx plus c. The function would be mx plus c for all x greater than equal to a. If you can define a function in such a way that it has 2 parts or more parts, we could have defined another part, like let's say this line also changes after some x equals to b where b is greater than a, then we could have added another part, right? So these are called piecewise functions, of course, because these are pieces of the function. And we are going to learn how to integrate this kind of functions. So let's begin. So let's do it here. Let's say we have a function, for example, y is equal to x for x less than 2. And then we have, since y is equal to x for x less than 2, and we can say y is equal to x squared for x greater than equal to 2. I hope this definition makes sense. If not, you can just understand it like this. So I will just draw a graph of this function here. So as again, this is our x and y axes. And in our axis, what we can do is, let's say this is the point x equals to 2. This function simply y equals to x, like this, right? The line through the origin making an angle of 45 degree with the horizontal x-axis. That is the line y equals to x. But this only applies up to x equals to 2. After which it becomes a parabola which looks something like this. So this is the point where it changes. Okay. So for all values of x greater than 2, this happens. Now we are asked to find the definite integral of, let's say, 0 to 4 y dx. What is the value of this integral? 0 to 4 y dx. So naturally, when you look at the function, it is defined differently from 0 to 2, and then again defined differently for 2 to infinity, right? So what we are going to do is, we are going to first break up the limits. You have known in definite integration that a to b fx dx, this integration, this definite integration can be broken down into 2 parts, a to c fx dx plus c to b fx dx if fx is continuous at all points between a and b and a less than c less than b. So now when we are doing this integral, we can break it into 2 parts, as I said, 0 to 2 y dx plus 2 to 4 y dx. So let's erase this part. We already know this part and make some space. So the integral I then can be written as 0 to 2 x dx plus 2 to 4 actually, 2 to 4 x square dx, right? Now we do know that the integration of x to the power n dx is simply x to the power n plus 1 divided by n plus 1. Well, we do add a constant plus c, but that is in case of indefinite integration. In case of definite integration, we simply evaluate it at limits, right? So following this rule, we can evaluate both of these integrals very easily. So let me erase this part, and we can write I is equals to, so 0 to 2 x dx, the indefinite integration of x according to this rule should be x square by 2, and the limit should be 2 to 0 plus, and then again this one should be x cube upon 3, and the limit should be 2 to 4, right? And now if we were to evaluate this integral now, so whenever we put 0, basically that function becomes 0 here, because it's only x square by 2 and x cube by 3. So we only need to evaluate the first one at the upper limit, which is 2 square upon 2, plus this one should be evaluated as 4 cube by 3 minus 2 cube by 3. So you first put the upper limit, put in the function, then do a minus, and then put the lower limit here. And you can simplify this, and whatever this will give, that is your required answer. So this problem is then solved. We can move on to another problem here. So I hope this was clear. If it was not, please let me know in the comment section. I will try to be more descriptive from the next time. So let's do another example actually, and this is a very important one. So let's do something like this. Let's say y equals to mod x minus 2. Let's say this is our given function. So here mod denotes the absolute value function, right? So whatever you put in, whether it be a positive number or a negative number, it will always come out as a positive number. So for example, mod of 5 is 5, but mod of minus 5 is also 5. So we are basically defining a variable function here in terms of mod. And we are asked to find the definite integration of 0 to 3 y dx. Now, how do you propose to solve this integration? Well, at first it might seem that if you were to just do x minus 2 dx, it would have been easy, right? Because you simply apply the formula of x dx and then 2 dx. But it's not so easy here, because the modulus function here, the absolute value function, basically behaves differently under different intervals. So if you were to actually see what this function actually is, you would see that y is x minus 2. This is x minus 2 only when this quantity is positive, which means x minus 2 is greater than 0, or in other words x greater than 2. So for all values of x which is greater than 2, the quantity is x minus 2. You can also write x greater than or equal to 2, because the 0 value is also covered. And this quantity is the negative of x minus 2, which is 2 minus x, for all values x less than 2. And you can see that this is actually a piecewise function. So now doing this integral 0 to 2, this part, we have 2 minus x dx, because under 0 to 2 the value y behaves like this. And then from 2 to 3 we should have x minus 2 dx. Do this integrations term-wise. 0 to 2 should be 2 times 2 minus, then again 0 to 2 x dx plus 2 to 3 x dx minus 2 to 3 2 dx. We can evaluate each of them. This one again is x square by 2, and when you put the values, it becomes 3 square minus 2 square by 2. This one becomes 2 times 3 minus 2. So to say in short, this is 4, this is minus 2, that becomes 2. This is 9, this is 4, 5 by 2. And this one becomes minus 2. So 2 and 2 cut off. The value is simply 5 by 2. That is our final answer for the integration. So that completes another example. Okay, so that completes both of our examples actually. And there are a lot of examples that could be done, but I would end this video right here. So if there are any doubts, you can let me know in the comment section about all the doubts and everything you have to ask. And if there are any future suggestions, please let me know. So I really hope you liked the video. I know there are a lot of improvements that need to be made, but I am trying my best. So please do subscribe the channel and like the video, and let me know in the comment section about how you like the video. Thank you.